So in version 3.8, Python introduced something called as a Walrus operator that facilitates assignment expressions. Assignment expressions are very similar to assignment statements, which is like a equal to 10, where 10 gets assigned to value to variable a. But as part of assignment expressions, what happens is the value 10 not only gets assigned to a, but gets also returned as a return value of this expression. So that we can reuse it at different places if we would want to. So these assignment expressions, they come in really handy while writing code. It makes code really intuitive to read and build. One really weird thing about assignment expression is a very simple looking assignment expression gives a syntax error. And in this video we'll be changing the we'll be diving into Python grammar and identifying why that happens, and in the process we would be altering the grammar in order to just get rid of that syntax error. Right, sounds fun, right? Let's jump into it. So before we go into Python grammar, let's understand where exactly the Walrus operator fits into the picture. By the way, the Walrus operator looks like a colon equal to, so an equal to prepended by colon. So what we'll do in order to understand where does this actually fit into the scheme, let's write our own shell in Python. So what I'll do it is I'll create a file called shell.py. By the way, since this was introduced in version 3.8, what I've done it is I've changed my branch to 3.8 so that I run 3.8 shell of Python and not run on Python 3.10. So you can do this by running a git fetch and basically using this very branch. So I would recommend you to do this and not use the Python 3.10. The entire code base that we are skimming through is for the version 3.8. So we'll jump on to writing a shell. Let's write a very trivial shell. What it should do it is it should continuously take in commands and fire that commands onto local shell, and this should continue until we see an exit statement, right? So what we would do it is we would take in a command as an input and we render a nice looking prompt. What we do it is until we get an exit command, we would continue our loop, and in the loop what we would do it is we would want to run that very command onto my shell. So I would do os.system and I would pass in that command so that this command gets executed onto my local shell and the output gets rendered. Once this is done, I would also like to take in the next command that I would need to run, and this is pretty much a very basic working shell in Python, right? So this works really nicely. Let's see this in action. So if I do python shell.py, it opens up a very nice looking prompt, and now what I can do it is I can do ls. So it did print every content that I had in my current directory. I can do a pwd to get my present working directory, and when I type exit, it gracefully exits the loop, right? And this is exactly what we want. Now let's be a little greedy, and the core logic of this shell is just 4 lines of code. What if I want to reduce it, right? So one very peculiar thing is our code is getting repeated. So we are taking input twice, once outside the loop and once within the loop. We have to take an input outside the loop so that our terminating condition looks similar, looks intuitive, rather than using a while true and using an if within it. This seems much more intuitive. So now what I would want to do it is I would want to get rid of this redundant piece of line where we do command equal to input, right? So as part of intuition, what you would want to do it is you would want to initialize the variable and take input in the as part of while condition, right? So something like this, right? But so this makes our code intuitive, and you want to define the variable and take input as part of condition itself and let this evaluate and use this particular thing as part of and use the value which is being input in command and put it against and basically compare it against the exit string. But when you run this, it would give you a syntax error, right? Because this is not a valid syntax. And this is exactly where your Walrus operator kicks in, where your assignment expression kicks in. Recall that assignment expression not only assigns the value, but it also returns the value. So now what would happen is, since we are using colon equal to, which makes this as an assignment expression and not just a simple assignment statement, it would take an input, assign it to the variable command, and now this variable gets defined in the scope and I can use it within the while loop. And since assignment expression returns it, so the anything that is being assigned to command gets also returned, so which takes a seat here, right? So now my inputted command will be checked against exit. If it is not exit, it would continue. If it is exit, then it would break, right? So if I run this, what I get, my bash opens well, and now I can do ls, it gets me all the file. I do pwd and I do exit. It gracefully exited my shell, right? So this is exactly where your Walrus operator or assignment expression fits in really nicely. So it makes your code look really intuitive. But what's the problem? The problem is very interesting. So I'll just open up a shell which I built using the very code that's there on my machine. It's running Python 3.8. This is very important. The code that we are browsing is of version 3.8. The grammar has been changed in version 3.9 onwards. So that's why the version 3.8 is very important for you to follow through. So now what we'll do it is, we have seen that a normal assignment looks like a equal to 10 and a gets value 10. Now instead of using assignment, let's try using Walrus operator. This gives a syntax error. This is very weird, right? So you would expect this to work as a normal assignment statement, but it doesn't. It instead gives us an invalid syntax. But if you thought this is weird or this is non-intuitive, wait. If I just wrap this very statement with parenthesis, it works. It works seamlessly and my value 10 gets assigned to A. If I do it with B colon equal to 10, and you'd see that B gets defined and the value 10 is returned as well. So this behavior is actually very weird, right? So what we'll be doing today is, we'll be understanding why this happens, and in the process change the grammar to get rid of this very syntax error. And when someone does a colon equal to 10, it should do a normal assignment, right? And it should basically define variable and do a normal simple assignment that we want to do. So let's jump into it. Let me just remake the build in binary and get everything set up. And now what I'll do it is, anytime we get syntax error, it mostly has to do with grammar of the language, right? So the grammar of the Python language is found in the file grammar, which is present in folder grammar. Again, version 3.8 is important. The file has been changed for version 3.9 and onwards. So the grammar is here. This is how the grammar of Python language is defined. This is where the Python grammar is defined. So now we know that we have to do something with a colon equal to operator. Let's look for colon equal to, and we find it at two places. This is something called named expression test. Another one is argument. This looks like the assignment expressions. Basically, Walrus operator is called as named expression in the source code. This usually happens where the terminology that goes for the outside world is very different from what's being used within the code base. So in the code base, this is used something called this is called as named expression. And now let's find out what named expression rules defines are. So named expression rule is find a test list comp something. It's find an if statement and while statement. Oh, this is interesting. So if I just move out while here, so if I named expression test over here, this is exactly how we used it, right? We used while, then followed by our assignment expression where we did command equal to input, and then this gets it a block. So suit is basically the new line and block that we do. With an indentation is called suit in the code base. So this is what is allowing us to use named expression in the while statement. With this logic, what it seems like, named expression we can also use it with if statement. Let's look for named expression again. We can use it with elif as well, while, and some simple named expression test looks like x colon equal to, so basically test colon equal to y, which is what named expression is how it's defined. And named expression test is also defined with test list comp. Looks something to do with list comprehension, not really sure, but let's look for test list comp, where exactly it is defined. Oh, it's just above. Oh yeah, here it is. See, what happens is test list comp is a named expression test or a star expression. Let's focus on named expression test for a while. And now this named expression test, now this test list comp has to be either wrapped by parenthesis or square brackets, right? So this is where the grammar is allowing a test list comp, in turn named expression test, to be wrapped around a parenthesis or a square bracket. So this looks like the place, or rather this is the place where that particular rule is defined, where a colon equal to 10 surrounded by bracket works is where is actually coming from this very statement. And now if you see, this very thing is something called as atom, looks like an atomic statement. It has round bracket, square bracket, which looks like list comprehension, normal, dictionary or set maker, having a name, number, string, none, true, false. Oh yeah, so this looks like a simple atomic statement that would be treated, which could be a yield expression or a test list comp or a dictionary set maker with surrounded by brackets. So this is the very rule that allows parenthesis that allows a colon equal to 10 within parenthesis to work just fine. Okay, now let's find out why a colon equal to 10 without any parenthesis doesn't work, right? So if you see, we could not find any rule that shows us that it is allowed to have a normal statement like that, right? So what Python does is, Python explicitly has set in an exception where assignment statements have been allowed, like a equal to 10 is allowed, is an explicit exception. So in order to find where that is defined, let's look out for quote equal to quote, basically single quote equal to single quote, in order to find where this is used. Oh, this looks ugly. We'll skip all the ugly things and find out simple ones, because I don't know what this is. Let's dive deep into some other time whenever I understand it. It has something to do with LL parser. Sounds familiar with our compiler course. Ugly. Let's skip it. Where arg list, variable argument list, something similar. This looks neat. So this single quote, single quote equal to single quote is part of an expression statement. This expression statement is part of a small statement. Small statement is part of simple statement, and simple statement is a statement. So if you trace back, it states that any statement is either a simple statement or a compound statement. Simple statement is small statement and a sequence of small statements separated by semicolon. This is exactly why we can write multiple smaller statements followed by colon, and this rule is the one that is actually allowing us to do that. Small statement can be expression, delete, pass, flow, global, non-local, assert, right? So this looks very familiar. And expression statement is test list star expression, something to do with test list star expression. Then assign is basically annotation assignment statement, where you can have a type definition. So for example, a variable called a specified with type int and equal to 1. So a colon int equal to 1 should be allowed. So this is where it's part of annotation assignment. This aug assign is basically augmented assignment, where you do plus equal to. So a plus equal to 10 would be is allowed by this. And we have seen an explicit or, and then we have an entire equal to part, and then we have an equal to statement, and then there is yield expression or test list star expression, and then followed by a type commit. So this is the place where assignment statements are explicitly allowed by the grammar, right? So now if we would want to allow let's say colon equal to, right? So we would be making change, because where a equal to 10 is allowed, we can obviously make a change and allow a colon equal to 10. So let's copy paste this entire thing and make a change to this grammar, and let's say we allow I'll just paste and we put colon equal to here. right? So if we have this thing, so with this thing what we have done it is we have not only allowed equal to like a equal to 10, but we have also stated ki allow a colon equal to 10 as well, right? So when we change any, so this looks like something that would help us get rid of syntax error, but let's find out. When we change any grammar, what we have to do it is make we have to run a command called regen grammar, make space regen hyphen grammar. It would regenerate the parser files for this grammar, and basically this grammar would actually take in effect. It actually changes the parser file which is auto generated, and then you would have to run normal make, which would build your binary, right? So now we have compiled this code into so we have basically baked this new grammar into our binary and see what happens. So I'll run python.exe, and first let's see that everything else is working fine. A equal to 10, does this work? It works. We had a colon equal to 10 part of a parenthesis, it should work, it is working. And now comes the part where we would want a colon equal to 10 to work. Let's run this. It did not give any syntax error. Let's see if a is 10, it has. Let me change this value to 20 and see what happens. A gets 20. So we got rid of syntax error, and we allowed a colon equal to 10 or a colon equal to 20 to work just fine, just as normal assignment expression, right? So so we have successfully changed the grammar and got rid of a syntax error, and something that that should have been intuitive to do, we have made it work, right? So we got rid of the syntax error and we achieved what we wanted. But how come by even by putting a colon equal to, how did it understand that we had to do an assignment? This should be the critical question that one should be asking. As in where exactly is that code that is treating this very thing as an equal to? Because we did not change anything in part of C, we did not change any file whatsoever. The thing, so this shell.file is something that we created, grammar is what we changed, this is the grammar parser file that was auto generated, but we did not explicitly handle a colon equal to be treated as an assignment. So where exactly is this coming from? In order to do this, let's look out for where expression statement is used. Let me just find expression statement in .c files. So when we look for it, we get an ast.c, which is an abstract syntax tree file for C, and let's open this, and what we get is, we get an, so we get something called as an AST for expression statement, which is how to parse and analyze expression statements. So what we see is, this should be the one that is handling expression statement, and which is the rule in which we made the change. So anything that had to do with colon equal to should have been done over here, it would have gone over here. So now what we see is it does NCH. What NCH is, NCH gives n के अंदर n children, which gives the count of number of children. Seems fair. So it gets the number of children that it has. So what it would have it is, when I'll have a colon equal to 10, it would give me number of children to be 3, because it's like a colon equal to and 10. So 3 children of my this very statement. If I do a equal to 10, again 3. Here it checks for if num equal to 1, which means if it has just one child, as in if I just type a and then I hit enter, then what I mean is I want to get the value of a and print it there, right? So this is what it would be doing. So yeah, so when number of child is 1, it is doing something, it is doing for test list and returning null, or if no error, then it is returning an expression, which basically treat this statement as a normal expression and evaluate it. Then it is doing, if this is, and obviously in our case a colon equal to 10 is not falling over here, then it comes over here, it says the type of child, first child of n. So first child of n would be the operator, which is like a colon equal to 10 mein colon equal to would be the 1. If it is aug assign, no, it is not augmented assignment, it is not augmentation assignment. Basically it's not plus equal to, into equal to, minus equal to, it's colon equal to, right? So it's not an augmented assignment. So this is going to be false. So then what? Then it has, is it an annotation assignment? No, it is not. It does not fall into this either. Then let's move to the thing. So it won't go into this else if as also. And then there is this massive else. It should be doing something interesting. It checks for first child to be equal to a normal assignment statement, and has type, does this type, has type command something. It's okay to not understand a few things at first. Even I don't understand this, but it would help us understand it. So we are just getting a gist of things. So if we scroll down, we see at the end it is returning assign. This is what is treating a colon equal to as an assignment. So since it was not an annotation assignment, it was not an augmentation assignment or an augmented assignment, it falls into this final else block, where as part of return, it is actually returning an assign node, which treats my entire expression as an assignment statement, and it does the needful. Right, so now we know why without explicitly handling colon equal to, we were able to basically implement a normal assignment flow while using a colon equal to. Right, so this is fun. Right, how basically without even changing the C part of it, without explicitly handling a colon equal to, we were able to basically mimic the behavior that we wanted to. So that is it for this video. I hope you guys had fun. I've written a very detailed article about it, titled "The Weird Walrus," and have put the link in the description below. Go ahead and check that out. You saw how easy it was for us to change grammar and implement an interesting functionality without really understanding the internals of C Python. I hope this paves way for you to explore the C Python internals. Basically, that is it from me. If you guys like this video, give this video a thumbs up. If you like what I do with C Python, give this channel a sub. I'll see you in the next one. Thanks a ton.